As an alternative to the independent samples t-test, you can use an ordinal type of analysis in the OM software. Now, for example, here we can see I've got a little contrived data set in which we have experimental and control individuals, and then we have gender, and then we have the main outcome variable here, or ordering, which is time. Let's say this is reaction time data. Now, let's also say that we're expecting the experimental individuals to have lower reaction times than the control individuals. So let's say that's our hypothesis, our expectation for this study. So the analysis can be found by selecting Analyses, Ordinal Analysis, and then Crossed Orderings. We're going to cross two orderings here. So we're taken to the option window here. Now quickly, a couple of things. You can select the data set to analyze here. So this is the data set we're looking at. You can see the orderings listed here. Now you can always sort these orderings. Here they're sorted according to how they are presented in the data set. If you want to sort them alphabetically, so let's say you have a really long list of orderings here and you want to find a particular ordering, then it might be handy to sort them alphabetically. So you can just select this button here and that will sort them alphabetically. If you click it again, it will sort them back to as they are presented in the data spreadsheet. You can also use this filter. Again, this is handy when you have a large number of orderings. And here we only have 3, so it's not really that handy. But just to show you how it works, let's say I want to find a particular ordering. And this is case sensitive, so you have to be aware of that. I just type in the ordering's name and then select enter. And then you can see it will just filter out everything else except that particular ordering. Now you can also use different letters. So if I want to find an ordering that has the letter G in it, again, type G and select enter. And there you have it. If I delete that, hit enter, then I'm taken back to the complete set or list of orderings. So this is a filter you can use, again, to find an ordering or orderings in a long list that you might have. Here we only have 3, so not really all that handy here. Okay, so the first ordering we want to move over is the main outcome ordering. In this case, it's the time. Now I can click it and then use the arrow. And then the second ordering we'll look at that we're crossing is the grouping ordering. And here it's a group. I can just double click it, in fact, and that will move it over automatically as well. Now what we need to do next is define the expected ordinal pattern. So we select this button here, and I'm going to magnify this little box here by using this image font size. I'm just going to click that up to make it larger so we can see it. Now here what we're doing is setting up the expected ordinal pattern. Now, as I said a few moments ago, what we're expecting here is for the experimental individuals to have lower reaction times than the control individuals. So that is our expectation. So I just click each box there, and that is the ordinal expectation. So I'll select OK, and I'm ready to run the analysis. We'll look at these other options in other videos. But let me say briefly, or describe briefly, what the analysis is going to do. It's essentially going to take every experimental person and compare that person's reaction time to every other control individual's reaction time. So starting for this first person in the experimental condition, that person has a 6. We'll compare that to the control, which is an 11. So 6 is less than 11, so that matches expectation. So that is a correct classification. Then we'll take the 6 and compare it to the next control individual, a 27. Again, 6 is less than 27. That matches expectation. So that is a correct classification again, and so forth. So we'll take that person, compare the individual's reaction time to all the other control individuals. Then we'll move to the next experimental person. So 12 versus 11. Now 12 there is greater than 11, so that does not match expectation. So that is an incorrect classification. So the software will iterate through all possible combinations or pairings of the experimental to control individuals. Again, pair one by one or pair by pair there. So we'll select OK to run the analysis. We're taken to the output text output window by default, and I'll scroll up a little bit here, and we can see the ordinal pattern analysis crossed ordering. So we get the label for the analysis we've run. Here we get the different options that we've chosen. Here we get the ordering frequency summaries. So we can see we have the reaction time here, 22 units there, no missing, no undefined. That all looks good. Groups, 2 units there, experimental control, no missing, no undefined. Here we get the defined pattern, and you can see the little blue crosses here that indicates the expected ordinal pattern. And then we get the classification results. I'll scroll down a little bit. So ordinal relations between pairs of observations classified according to the defined pattern. When you work through all possible pairs of experimental and control individuals, there are 56 possible pairs there. Of those, 49 matched expectation, matched the ordinal pattern. And so that's 87.50%. So that is our percent correct classification. And that's a pretty high value. So most of the time, if you take any experimental or control individual and set them side by side, the experimental score is lower than the control score. How frequently? 87.5% of the time. So that's a fairly high PCC. Now we also get these paired ordinal results here, and I'm just going to hit enter here a few times so I can scroll this up so we can see it. Now in this case, this is redundant with the classification results because you can see here the experimental versus control. We only have two groups we're comparing. If we had three groups, let's say we had another experimental condition here, then we would get all the pairwise comparisons between those groups. But here it's just experimental less than control, and we can see the exact same numbers as above, 56 classifiable pairs, 49 correctly classified, and there's our 87.50 again. So this is redundant in this particular example. So this is one alternative then to running an independent samples t-test on your data.